Okay, ladies and gentlemen, this video is the first of several parts on understanding z-scores. Okay, and the place I want to start is, now that you're doing statistics with normal curve, that's where z-scores come in, because the z-score is basically how far a value is from the mean in terms of standard deviations. How many standard deviations above or below the mean. Okay, and but anyways, without getting into much detail about that, the thing I want to make sure you understand is here again is just a small snapshot of a typical z-table, right? And the thing I want you to understand is all of these values you see on here is basically embedded in your TI-83 or 84 calculator. Okay, so as we do these next set of problems, I also want to point out that basically we're just going to stick with mainly inverse norms and normal CDFs with a lot of our normal curve calculations. And if you follow the light blue, here is your normal CDF. And by the way, what we'll find out with our calculations, we'll never ever do normal PDF, because we're not going to find probabilities at a set value or set point. We're going to do cumulative, like percent rank values. Okay, and that's where normal CDF comes in. And if we know the percentage and we want to know the score to get there, that's why we do inverse norm. Okay, so anyways, let's get to the problems, and hopefully you'll follow along. And the key thing to understand, guys, is I will never reference that z-table I showed you. I'm going to teach in the context of what you do with your TI-83 calculator. Okay, so here's one of the problems presented to me. It says, for a normal distribution, so that right there tells you, hey, I'm going to do z-scores. Right, I have a normal curve. It says, find the z-score that separates the distribution as follows. They want the highest 30%, they want the lowest 40%, they want the highest 75%. So let's just take these one at a time. And the first thing I want to remind you guys is, please remember, always do a sketch. Okay? Whenever they say normal curve, the first thing I instantly do is I'm going to do a sketch. It doesn't have to be perfect. I just want a picture to look at. Okay? So we're going to use this one for problem A here. And if they want the highest 30%, so follow the green. We'll use green on this one. Does everybody understand the highest 30%? Well, we know the middle splits at 50-50. Well, the highest 30% is probably somewhere. Again, I'm kind of guessing. The highest 30% is probably starting about right there and going to positive infinity, right? And the key thing to think about, though, is if this in here is 30%, that's the highest 30%, that's where we want to be. What about all this behind it? And that's the key value you need. Okay? Now I'm going to reference the z-table one more time, because the one thing I need you to understand is I want you to notice here and here, no matter whether you're negative or positive z-score, it's always starting at negative infinity, and you're finding the values going towards the mean, right? Or in case over here, basically you're always reading from left to right is what I'm referring to. You're always going from left to right. Remember that. Always going from left to right. So why is that important? Is because I'm not going to use 30%. I need to understand that what they're really asking me for is, how do I get to the top of the 70% mark, which is actually right there. Okay? So long story short, we're going to go ahead and do inverse norm, because we have the percentage, right? Remember, we have the percentage. So we're going to do inverse norm, and we're going to find what value we need to get us to 0.7. Okay? And that's what we're going to do on our calculator. We're going to do inverse norm 0.7. Does that make sense? So guys, I want you to try that. Now, here again, what you're going to do is do second vars on your calculator, second vars, and that's going to give you to this menu, and you're going to select choice 3, and you're just going to do inverse norm, select that, and put in 0.7. Okay? So, again, pause the video and see if you can do inverse norm 0.7. Okay, let's see how you did. When you did inverse norm 0.7, did you get 0.5244? 0.5244. If you did, what that means is that right there is 0.5244 standard deviations above the mean. Okay, let's pick up the pace here a little bit. So if I'm going to do B, what's the first thing I'm going to do again? I'm going to do a quick sketch, right? And for B, if I want the lowest 40%, does everybody agree the lowest 40% is going to be somewhere just below the middle 50% mark? So this is what I'm looking at. I'm trying to find that value right there. That's at the 40% level, right? The 40% level. And so what am I going to do to figure that one out? I'm going to do inverse norm 0.4. I'm going to count from negative infinity all the way up to that 40% rank level, right? So again, pause the video real quick and do inverse norm 0.4. Okay, did you get negative 0.2533? If you did a great job. You see that mark right there is 0.2533 standard deviations below or less than the mean. Below or less than the mean. Okay? Alright, finally let's do C. What's the first thing we're going to do? That's right, we're going to do a quick sketch. And this time they want the highest 75%. So let's think about that one a little. Where the heck would be the highest 75%? Well, wouldn't that mean I would be actually somewhere down below here, all the way up to positive infinity? In other words, I want that value there that's at the 25% mark, right? Remember, you always have to look in terms of the left side. You're always going from left to right. So does everybody agree what I really want is the bottom 25%? So what am I going to do? Inverse norm. Sorry, that's a little messy. Let me try that again. I guess, yeah, I'll use, I'll stick with purple. I'll put in the white section here. Inverse norm, right? Of what? 0.25. 0.25. So guys, please pause the video again and do inverse norm 0.25. Okay, what did you get? Did you get negative 0.6744 something? What that means is you are 0.67 or over half of a standard deviation below the mean. You're at 0.6744 standard deviations below the mean. Okay? So pause the video again before I change the screen. Okay. So, hopefully we're getting acquainted with the calculator, guys. And I just want to quickly do at least a couple more problems here. Okay. So, problem 5. I know they're giving me a z-score, so I'm going to do a quick sketch, right? Alright. And if they want a z of 1.17, now notice it's positive. That means if the middle mean is there, I'm going to go above it 1.17 standard deviations, right? Well, how do I find that calculation? Well, here's a real quick, short to the point lesson, guys. Because I'm actually trying to find the percent value, okay, I'm trying to find the percent value this time, I'm going to use normal CDF to tabulate that percent rank. Okay, that percentage that we need. We have the score, but now we need the percentage of it, right? So that's why we use normal CDF. So anyways, going back to the problem here, guys, to figure out 5A, I'm going to do the normal CDF. Normal CDF. Okay, normal CDF. And here's the thing. Remember, it reads from left to right. So if I want that mark right there, oh, they did tell me between the mean and that z-score. So does everybody understand? I'm going from the mean to that 1.17 standard deviation mark, right? So what I have in green is simply represented by normal CDF, right? Now, what is the mean, guys? The mean value, if I'm in the middle, is 0. Okay, because 0 standard deviations above or below means I'm at the mean, right? So I'm going to go 0 to 1.17. So pause the video, guys, and do normal CDF from 0 to 1.17. Okay, so how did you do? If you did this correctly, guys, normal CDF 0 to 1.17, you should have gotten 0.37899. So if we round that off, that's approximately 38%, right? That means that green area I shade in is 38% of the data. Okay? Now, because we're running long on the video, guys, let's just do one problem more, B, together. Okay? And if you look at B here, again, how am I going to approach it once again? That's right, I'm going to do a quick sketch, right? And this time, they want the area between the mean, which is, again, the center of my distribution, to a z-score. Notice the negative. That means I'm going to go 1.137 below the mean, right? I'm going to go 1 and a little bit more there. But I'm trying to find the area that's from that negative 1.37 all the way up to the middle mean, right? Which has a z-score of 0. Now notice, guys, how I just phrased it. So when I do normal CDF, because remember, I'm trying to find a percentage, and I already know the score, right? It was in z negative 1.37. So I'm trying to find, so that's why I'm using normal CDF, okay? But notice I always read from left to right. So what's the left mark? It's right there, right? The left mark, let me use red here, right there is negative 1.37. And I'm going up to the mean, they say, which is 0. So pause the video one more time and do normal CDF, negative 1.37, comma 0, and see what you get. Okay, guys, if you did it correctly, you should have gotten 0.4146 something, which is approximately 41%. In other words, what I have shaded in blue from the mean all the way back 1.1 or 1.37 standard deviations from the mean is 41% of the data. So guys, pause the video one last time. And guys, hopefully, even though this video ran long, you followed through with it. Sorry, stats does take a little bit more explanation, doesn't it? But until next time, bye.